out the problems, it's good. So now we will take second example, that is f of x is equal to x square in the interval minus pi to pi. So here, so the width of the interval is 2 pi, that is nothing but period, 2 pi is the period, and x square is an even function in this interval minus pi to pi. F of x is equal to x square is an even function, so no need to compute the sign terms of the in the Fourier series. So that means I can directly say that the function is even, it contains only cosine terms, hence the Bn, that is 0. So with this, the Fourier series, the required Fourier series is x squared is equal to a naught by 2 plus n from 1 to infinity a n cos nx. So here a naught and a n we need to calculate. Okay, so I hope we have, I think that formula for the a naught is 2 by t integration from c to c plus t f of x into dx. Okay, so then here today I am not able to write anything today. So due to the hard one software is not installed, I just explain only one example. So f of x is equal to x square a naught by 2 plus summation a n cos nx. Okay, because here period is 2 pi and that 2 pi divided by t get cancelled. Okay, now as for the Euler's formula, a naught is equal to 2 by t integration c to c plus t f of x dx. So here period is 2 pi, t is 2 pi, and lower limit is minus pi to pi. So that is 2 divided by 2 pi integration from minus pi to pi x square dx. Since it is an even function, instead of writing this, we can write 2 times 0 to pi x square also. If you write, it's okay, or else since it is x square is a simple function, we can integrate in the interval minus pi to pi directly. Okay, so that becomes the integration of x square is x cube by 3, limits from minus pi to pi, so 1 by 3 pi, so this 3 is constant, and pi cube, upper limit is pi cube, minus of minus lower limit, so lower limit is minus pi, actually this is minus pi whole cube we can write, or minus pi cube also is correct. So minus into minus plus 2 pi cube divided by 3 pi, so everything pi cancelled, we get a naught is 2 pi square by 3. So this is our a naught. So that is 2 pi square by 3. Next we need to compute another unknown, that is a n in equation 1. So a n is defined as a n is equal to 2 by t integration from c to c plus t f of x cos 2n pi x by t into dx. So since period is 2 pi, so 2 pi by 2 pi get cancelled, we get cos nx, and f of x is x square, it is given, f of x is equal to x squared is given. You take all these inputs, it becomes a naught is a n is equal to 1 by 2 divided by 2 pi integration from minus pi to pi x square cos nx into dx, and after simplification we get 2 by pi. So since it is an even function, x square is also even, cos nx is also an even, product of even function is even. So we can, instead of integrating from minus pi to pi, we can integrate 2 times 0 to pi. So this becomes, this 2 is because of the even functions definition. So that 2 divided by pi integration from 0 to pi x square cos nx. Now as we said, by parts rule or Leibniz rule we can apply here. So first function into integration of second function minus derivative of first function into integration of already integrated functions, like that we need to integrate this. So we take 2 by pi, first function x square, integration of cos nx is sin nx by n, minus derivative of x square is 2x and integration of sin nx is minus cos nx divided by n. We have already n, so n into n square, plus integration of 2x is, sorry, derivative of 2x is 2 and into integration of cos minus cos nx by n square, so its integration is minus sin nx by n cube and the limits from 0 to pi. Okay, so this is a simple by parts, so you can apply. So an is equal to 2 by pi. When you put the upper limit sin n pi, we know that sin n pi is 0. Cos n pi, so sin n pi is 0, that is pi square. Pi square into sin n pi is 0, so this term is 0, minus into minus plus 2 into pi, so that is 2x, x is replaced with pi, 2 pi by n square cos n pi, plus into minus minus sin n pi again 0, so first term and last term for the upper limit is 0, same for lower limit because sin 0 is 0. So next, since it is lower limit is 0, we have a multiplication x, so all the three terms will be 0 for lower limit. Okay, so only we have a terms 2 pi by n square into cos n pi. So this cos n pi is minus 1 power n cos n pi. So multiply, pi get cancelled. So 2 divided by pi into 2 pi by n square. So we get 4, 2 into 2, 4, pi get cancelled, 4 by n square into cos n pi, which is nothing but minus 1 power n. So this is an. Now substitute a0 and an into equation 1, we get a required Fourier series expansion for the x square function. So that is pi square by 3.
Excuse me, sir.
Yes sir, yes.
What's the value of t?
What is?
What is the value of t?
T is 2 pi, the period. So the difference in the interval is the period. If it is not given, you have to take the difference of this interval. Upper limit, okay. Sorry, this is pi, minus of minus pi is 2 pi.
Okay, sir, okay.
So that is the value of period actually. Actually here in this question we have to specify that f of x plus 2 pi is equal to f of x. So that is not specified. So they are not specified that actually it should be specified. So if it is not specified, you are using a Fourier series. It's nothing but if you take a difference of the interval, you get a period. That period is 2 pi in this example. Okay, is that clear for a0 and an? So substitute a0 is 2 pi square by 3, so a0 by 2 becomes 2 gets cancelled, pi square by 3, that is pi square by 3, plus 4 is constant, you can take 4 outside, summation n from 1 to infinity minus 1 power n by n square into cos nx. So as n takes the values, we get a series. So this is the required Fourier series expansion for the function x square in the interval minus pi to pi with period 2 pi. So similar example that is given in 3. So f of x is mod x in the interval minus pi to pi. So here this mod x is, as you know, it is a even function. Now we have the interval is minus pi to pi, so the width of the interval is 2 pi, again period is 2 pi, so here f of x plus 2 pi is equal to f of x. So this is the details given in this example. So by looking into the function, we can decide whether it is even or odd in the given interval and the period. So with that information, we can say that the Fourier series contains only cosine terms. It not contains the sine terms. So that means Bn is 0 again in this case, in this example also. So as I said, Fourier series expansion for the even given function, that is nothing but even a naught by 2 plus summation n from 1 to infinity. Since period is 2 pi, so this becomes cos nx only again. Okay, so now compute a naught and an. So a naught is definition 2 by t integration from minus c to c plus t f of x into dx. So here the period is 2 pi, so 2 divided by 2 pi, limits from minus pi to pi, c is minus pi and t is 2 pi, so we get minus pi to pi. F of x is mod x, f of x is mod x, and so since it is an even function, we can split actually the definition of mod x is that is equal to negative x if x less than 0 and that is equal to positive x if x greater than 0. So now I want to take an interval x greater than 0. So since it is an even function, I can write it is 2 times that integrand. So that is 2 by pi into 0 to pi f of x dx. So the function value in the interval 0 to pi is plus x. So we can take positive x. So that becomes 2 by pi integration from 0 to pi mod x dx. So that is mod x in the interval 0 to pi is positive x, and if you integrate this x, we get x square by 2. So put the limit 0 to pi. So simplify 2 by pi, upper limit is pi square minus lower limit is 0 divided by pi 2, divided by 2. So 2 to get cancelled, we get a naught as pi. So this is a naught value. Similarly, an is 1 by 2 by t integration c to c plus t f of x cos 2n pi x by t. Again, since we have a period 2 pi, it is cos nx, we get cos nx, and f of x is mod x in the interval minus pi to pi, and 2 by 2 pi, 2 by 2 cancel, we get 1 by pi here. So that becomes 2. Again, since it is an even function, mod x is even function, cos is even function, so the whole product is again even function. I can write it is 2 by pi 0 to pi. In the interval 0 to pi, mod x becomes x, positive x, so x cos nx. Again, product of two function. So I can use let this rule. So first function into, that is 2 by pi into, first function into integration of cos nx is sin nx by n minus derivative of x is 1 and integration of sin x by n. So this entire term we have to integrate. So integration of sin is cos minus nx divided by n into n square, limits from 0 to pi. So that becomes 2 by pi. So since if you put an upper limit, sin n pi is 0. If you put a lower limit, sin 0 0. So the whole first term for both the limits it is 0. Minus into minus plus 1 by n square cos n pi, the cos nx again 0 to pi, the limits they are specified particularly. So that becomes 2 by pi, 1 by n square is constant. So upper limit cos n pi minus cos 0. So this gives 2 by n square pi, cos n pi value is minus 1 power n and cos 0 value is 1. So this is what the function, and here we can simplify this in terms, that is minus 1 power n minus 1. So minus 1 power n, its value is 1 if n is even, if value is minus 1 if n is odd. So in another word, 1 minus 1 becomes 0. That means if n is even, we get a 0, an is 0, and if n is odd, we get a 4 times 4 divided by n square pi. So that is clearly an is equal to 0 when n is even, and an is equal to negative 4 by pi n square when n is odd. So using this we can write a Fourier series expansion for a mod x is, so a naught is pi and the Fourier series expansion is pi by 2, negative 4 by pi is constant, summation 1 from n from 1 to infinity cos nx by n square, n is odd. If n is odd we get this, otherwise we get a 0. So if you expand this we get a series like this. So this is the second example for Fourier series expansion, and we have a simple definition for verifying a odd and even function when if the function is in a piecewise function. If the function is piecewise, so f of x, that is piecewise function, is defined as f of x is equal to phi1 in the interval minus a to 0 and phi2 in the interval 0 to a. So piecewise functions. So to verify whether it is an even or odd, yeah, obviously if you see the graph of that function you can tell. But in this case, to verify whether it is even or odd, if phi1 of minus x is equal to phi2 of x. So if you replace this phi1 with negative x, if you get a phi2, then the function is even. Otherwise, if phi1 of negative x is equal to minus phi2 of x, the function is odd. So some cases it is not defined in the interval minus a to a. If it is not defined in the interval minus a to a, then suppose if it is defined in 0 to b with the intermediate point as a, so in that case there is a difference we need to compute. The difference is the end point limit, the endpoint interval, that is b, that we have to take with the x. So phi1 of b minus x, that is very important. Phi1 of b minus x, that gives you phi2 of x. Then the function f of x is even. Otherwise, if phi1 of b minus x is equal to negative phi2 of x, then the function is odd. So that is, please note this point, how to determine whether it is even or odd for a piecewise function is given in this definition. If the interval is defined in minus a to a, and if the interval defined in 0 to b with an intermediate point, in that case we have to take b minus x. Please check, it should be b minus x. So otherwise, if you are able to draw a graph, you draw the graph and it will also give whether it is even or odd. So here we have an example, that is obtain the Fourier series of the function f of x is a piecewise function, minus 1 in the interval minus pi to 0 and 1 in the interval 0 to pi. So the graph of this is a sawtooth function. It is, if you see, it is a symmetricity about origin. It's not a symmetric about y-axis. It is symmetric about origin. So from the graph I can say it is an odd function. And to verify this is odd or even, so what we will get? First condition, as I said, first if you take. So what is, so let me denote this as phi1. Phi1 is minus 1 and phi2 is plus 1. So phi1 of minus x. So if I take phi1 of minus x, so minus into minus, so we'll get a plus 1. Okay, so this is phi1 is minus 1 and phi2 is plus 1. Let phi1 of x is minus 1. This implies F1 of minus x. I'm sorry, it is an odd function, right? Phi1 of minus x is minus 1. So this is nothing but minus of phi2 of x. So then the function is odd function. So this condition it will satisfy. So this is an odd function. So therefore f of x is an odd. Hence we have it, the Fourier series gives you only the sine terms. It does not have a cosine terms. In other words, a0 and an both are 0. So here, as we said, the period is difference of the limits, that is 0, minus pi and pi, the end point limits, not the intermediate points. So 0 is the intermediate point and minus pi is the end point. The difference is 2 pi. So here period is 2 pi. So therefore by the Fourier series we get f of x is equal to summation n from 1 to infinity bn sin nx. So with that bn is equal to 2 by t integration from minus c to c plus t f of x sin 2n pi x by t. So with that t is 2 pi, substitute the t, simplify, we get 2 by 2 pi and c is minus pi, c to c plus t. So we get integration from minus pi to pi f of x sin nx dx. Okay. So here that is, this gives, so if it is an odd function, so given function is odd and we have that is 2 by pi, 2 times that area, 2 by pi 0 to pi sin nx dx. So which becomes 2 by pi, integration of sin is minus cos nx by n, limits from 0 to pi. So that becomes minus 2 by n pi into cos n pi minus 1. So cos n pi value is minus 1 power n and we have negative sign of minus 1 power n minus 1. We take negative sign inside. This is for the function bn becomes 2 by n pi, 1 minus of minus 1 power n. Again this is, if n is even, this term is 0. If n is odd only, we get a non-zero terms. So simplify that, the required Fourier series f of x is 2 by pi summation 1 n from 1 to infinity bn, that is 1 minus 1 power n divided by n sin nx. If we expand this for an odd function, we get, for odd value of n, we get 2 by pi 2 sin x plus 2 by 3. So that 2 we can take it outside, 4 by pi I can write sin 3x plus sin 5x and so on. So this is the Fourier series expansion for the given f of x. So this is for an odd function. So again we get the even function, that is this example 5 is same as the example 3. We have discussed example 3. So example 3 is mod x in the interval minus pi to pi. So this is the same example only, is given in another way around. So instead of taking my mod x, it is given as minus x in the limit minus pi to 0 and plus x in the limit 0 to pi. So we get a same result for fifth one. No need of will. So what is that function we got? That is pi by 2 minus 4 by pi. So finally we get the same answer. Now it should be right. Somewhere. Is it? Oh, yeah, here pi by 2 minus 4 by pi, same. So the answer we get because the problem is same, we given in a different way. Okay, this problem number 5 and problem number 3 both are same. The ex, way of explaining the problem is different. So the answer again it is same as that. So what about this function? Example 6, is it a even function or odd function? Anybody? Is it even or odd? Anyone in the online? Is this problem 6 is even or odd?
Odd function, sir.
Oh, no. How it is odd? If you take, if you replace, so this is if you take this first 2 into 1 plus x, replace x by minus x. So what I will get? I will get 2 times 1 minus x. Is there 2 times 1 minus x as a phi2? Phi2 is 0, right? So this function is neither even nor odd. We cannot say anything very odd and even. The neither even nor odd. We will not get a negative times of the negative times. We don't have a negative times of this in phi2, and we don't have a even after replacing x by minus x, we don't have a same function in phi2. So phi2 is 0. If it is 0 or constant and phi1 is a function of x, we cannot say anything about odd and even in this piecewise function. So here in this example, we need to compute all the three, a0, an and bn. Okay, so that is the given function is neither even nor odd. The required Fourier series is f of x is equal to a0 by 2 plus summation n from 1 to infinity an cos 2n pi x by t plus summation n from 1 to infinity bn sin 2n pi x by t. So here it is given period is 2. F of x plus 2 is equal to f of x is given. So that gives f of x is equal to a0 by 2 plus summation n from 1 to infinity an cos. So t is 2, 2 get cancelled, n pi x plus summation n from 1 to infinity bn sin n pi x. So it's a Fourier series we are using a period. So a0, here a0 is defined as 2 by t integration from c to c plus t. So c is the lower limit, that is minus 1. So that is 2 by t minus 1 to plus 1 f of x dx. So since period is 2, 2 by 2 get cancelled, limit from minus 1 to 1 f of x dx. So we have a piecewise function. The function is phi1 in the interval minus 1 to 1 is different from phi2 in the interval 0 to 5. So given the interval minus 1 to 1, we need to split in the required format. So minus 1 to 1 plus 0 to 1. So minus 1 to 1, minus 1 to 0 f of x dx plus 0 to 1 f of x dx. So the function in the interval minus 1 to 1 0 is we called as phi1, and the function in the interval 0 to 1 we called as phi2. So this is 2 into 1 plus x is phi1 and 0 is phi2. So I can directly say that this 0 to 1 is 0 because integrand itself is 0. We will get 0 here. So only the function is minus 1 to 0. So a naught is minus 1 to 0, 2 times 1 plus x dx, and that becomes minus 1 to 0, 2 into 2x dx. So integration of 2 is 2x and integration of 2x is x square. So after that we get, you substitute the limits, upper limit is 0, so upper limit both the terms 0, and the lower limit is, so we get lower limit minus 2 and minus 2 minus 1 square. So 2 get cancelled. Minus 1 square value is 1. So minus 2 minus 1 is, sorry, minus 2 minus 1 is, minus 2 plus 1 is minus 1, and since it is a lower limit, minus of minus plus, we get plus 1. So in other word, so 2 into upper limit, 2 into upper limit minus lower limit, this should be negative, okay, and plus upper limit minus lower limit, minus of minus 1. So the answer anyhow we get plus 1. Minus of minus lower limit is plus 1. Yeah, answer is 1. So a naught is 1, and similarly an is defined as 2 by t integration from c to c plus t f of x cos 2n pi x by t. So period is 2 and limit is minus 1 to 1. So minus 1 to 1 again further splitted as minus 1 to 0 and 0 to 1. 0 to 1 it is 0. So I can directly skip that term. So this becomes minus 1 to 0. So 2 into 1 plus x cos n pi x dx. So again 2 is constant, we can take outside. So this whole term 1 plus x is a first function, cos n pi x is a second function. So first function into integration of cos is sin n pi x by n pi minus derivative of 1 plus x is 1 into integration of this sin n pi x by n pi is minus cos n pi x by n pi whole square, that is nothing but n square pi square, limit from minus 1 to 0. So when you put upper limit, sin 0 is 0. When you put lower limit, 1 minus 1, 1 minus of minus 1. So and sin, you get sin n pi. When you put lower limit, sin n pi. So with negative sign, sin n pi is 0. So for both the upper and lower limit, this term is 0. Minus into minus plus, cos 1 by n square pi square is constant, and cos 0 is upper limit, cos 0 is 1 minus of lower limit, cos n pi, even negative it is positive only, cos n pi it is minus 1 power n. So with this simplify, we get 2 by n square pi square, and again as I said, this term is 0 if n is even, and it is plus 2 if n is odd. So with that, a naught is 1, an is 4 by n square pi square when n is odd, and bn, the other term is bn is 2 by t integration from c to c plus t f of x sin 2n pi x by t dx. Again t period is 2, so 2 by 2 cancel, and limit, we need to split this limit as minus 1 to 0 and plus 0 to 1. So in the interval 0 to 1 the function is 0, so it defined only in the interval minus 1 to 0. So f of x is 2 into 1 plus x sin n pi x dx. So again this 1 plus x is first function, sin n pi x is the second function, 2 is constant, we can take it outside. So 2 into first function into integration, integration of sin is minus cos n pi x by n pi minus derivative of 1 plus x is 1 into integration of cos is sin with the same negative sign, sin n pi x by n square pi square in the limit minus 1 to 0. So simplify, bn is equal to 2 into, when the upper limit x equal to 0, we get So negative. So 1 plus 0 is 1 and cos 0 is 1 minus 1 by n pi. So if you take minus 1 by n pi outside, so upper limit is 1 and when you put a lower limit, again cos 0 is 1, 1 into 1, 1 with a negative. So sorry, 1 into this term is 0, 1 minus 1. So this term will be 0. So when you are replacing a lower limit, so for lower limit we get a 0 plus minus into minus plus. For upper limit sin 0 is 0 and for lower limit sin n pi is 0. So both upper and lower limit second term is 0. So this gives Bn is minus 2 divided by n pi. So substitute all this in the Fourier series. So the required Fourier series is a0 by 2, that is 1 by a0 is 1 by 2 plus summation n from 1 to infinity. An is 2 divided by n square pi square into 1 minus half minus 1 power n is the an into cos n pi x plus Bn is negative. So that is summation n from 1 to infinity minus 2 by n pi into sin n pi. If you write this is enough for a Fourier series. So similarly we have another example, the last example. I think this is the last example. Yes. So here the limit is a general limit. So period is L. So this is L, period is L and the function is even. So because if you see, so this is 0 to L, it is defined, not a minus L to L. So when you define 0 to L, what you have to take the given function phi1 of b minus x you have to take. So that is b is L, phi1 of L minus x. So you compute phi1 of L minus x. So phi1 of L minus x is equal to, so phi1 is kx. So replace x by L minus x. So k into L minus x, which is nothing but phi2. So since phi1 of b minus x is equal to phi2, hence it is even function. So only cosine term appeared and sine terms are zeros. So the rest of the problems is same. So period is L here in this case. Period of this 7th example is L. So it is 2 by L. You will get 2 by L, and according to this you have to integrate 0 to L by 2 and L by 2 to L. You have to split that 0 to L in as two integrands, 0 to L by 2 plus L by 2 to L, and corresponding function you have to take and integrate. So since it is an even function, you can simply write 2 times any one, so you will get the same answer. Okay, so and similarly compute an, so you will get a required an is kl divided by n square pi square, again minus 1 power n minus 1. So you get a required Fourier series, and this is all about problems on Fourier series. If you have any doubt in the Fourier series, you can discuss through WhatsApp while solving. If you come across, if you are not able to understand any terms in the notes, you can directly contact through WhatsApp so that you can get a help from me. So I think this is Fourier series is simple. If you remember Fourier series and a0, an, bn with how to compute period, and if you notice even and odd, the calculation will, the time of calculation will reduce. If you are not notice even and odd, so simply go on calculate, which is not the terms which is easily becomes 0. That is one I suggested. So any other issues and are any other doubts in the Fourier series? So we have taken a problem here. Period is 2 pi. Period is, general period is L. So the last example, I mean, if you understand the interval from C to C plus T, you can solve any periodic functions in that interval. It means, what is the use of in the period 2 pi is, the cos function becomes cos nx. If it is other in period 2 pi, it should be 2n pi x by some L. So where L is period. So like instead of T, here is we have taken L. I mean, both are same in other words. So in any general period also we have discussed the examples. If you need more example, definitely we'll discuss more example on this only Fourier series. So if you need more example, inform me before the class commences. I mean at least one day or one night before the class commences. So you have a class on Wednesday. If you need a more example on Fourier series, let me know today or tomorrow, so that I can make a notes. I can type the notes of the examples and I can discuss. Okay, so we will further reduce Fourier series. So that is another topic called as off-range Fourier series. So we'll see again, the off-range is nothing but it is sine, or it contains only sine terms, or it contains only cosine terms. So that we'll discuss in the next class. So any issues? Any doubt? So that's all today's class. I check these messages. I think I have shared this notes, Mohammed. So I mean, yeah, this file it contains few more examples. Definitely, I will share this file also. Yeah, sure. Yeah, definitely I will share this file. Okay. Can you try this? I'm not sure. It is set to on. Yeah. In the chart, I have attached a file. Is it possible to download? Please check. I'm sorry, because yeah, today I was a little bit fast. I'll take one more class to explain this. Today this Epic pen is not working in this system. That's the problem. I'll take one or two examples and that particularly last examples and discuss once again in the next class. Please check, Muhammad, is it possible to download the attachment what I have given in the chat box? Yes, anybody try?
Sir, send the
I'm sorry. Oh yeah, I'm sorry. Now, please try, anybody? It is sending still, wait. Oh, sorry, sending is failed. Okay, I'll share you through WhatsApp. So thank you everyone. Thank you.